Welcome to The Debate. If you want an AI agent to build, say, a complex financial model, giving it access to more tools might actually make it dumber. Today, we are looking at a pretty fascinating paradox in modern software engineering. We are provisioning these artificial intelligence agents to handle increasingly complex tasks, and the natural instinct as developers is, well, to equip them with massive, comprehensive toolkits.
Right, you just want to give them everything.
Exactly. But does exposing an entire schema of capabilities actually empower an agent? Or does it mathematically dilute its ability to focus and execute?
It is really the defining architectural tension of the agentic era. You have this reasoning engine. Do you give it unrestricted access to a giant workshop so it can improvise, or do you hand it exactly one tool at a time on a highly controlled assembly line?
A very rigid assembly line in some cases.
Yeah, absolutely. Because every single tool you add to its peripheral vision costs you computational latency, it costs money, and most importantly, it costs reliability.
So to ground this discussion, we are looking at a highly specific, very elegant piece of source material. It's the Phraso/XL Agent Skills Repository. This is basically a suite of 25 distinct Excel operations, and it's built entirely on OpenPython.
Which is great because it means it interacts directly with Excel files using Python, completely headless.
Right, you don't even need Microsoft Excel installed on the machine. But what makes this repository such a brilliant case study is that the author built two entirely different architectures for provisioning these 25 tools to an AI, right, side by side.
Yes, it exposes the trade-offs perfectly. You have what we can call the full server approach, which basically dumps the entire capability landscape right into the agent's lap. And then you have the minimal path, which is a highly restricted token-optimized architecture.
And the central question we are debating today is straightforward. When you are building cost-efficient AI agents for production, do deterministic, minimal toolpaths outperform dynamic full-schema discoverability? I will be arguing for the full-server approach. It runs over standard I/O, streamable HTTP, or the Model Context Protocol.
The MCP.
Yes, MCP, which is essentially a standardized way for an AI to handshake with a data source. You load the comprehensive JSON schemas for all 25 Excel tools directly into the agent system prompt. That establishes a baseline of roughly 2,379 tokens.
Which is a heavy upfront cost.
It is, but what you buy with that is complete dynamic discoverability. The AI can look at the whole board. It can autonomously read a file, realize it needs to manipulate a specific column, pivot to writing data, and finish by generating a chart, completely unprompted by the human engineer.
Right, and I am arguing for the counter-architecture, the minimal path, because I believe it's vastly superior for production-minded software engineers. Instead of running a heavy server process and front-loading thousands of tokens of schema, you rely on a folder of tiny markdown summaries located in the repository Slate directory.
So just tiny, localized text files.
Exactly. When an agent needs to do something, it only receives the specific, localized document for that one action paired with a dedicated Python runner script, like run/xlcli.py. By doing this, the baseline cost drops from over 2,000 tokens down to just 446 tokens.
Wow. Okay.
Yeah, and individual operations cost a mere 18 tokens. So for a standard 3-operation workflow, the full server burns 293 tokens on tool schemas alone. The minimal path uses 54. That is a 5x reduction. I argue that in a production environment, that kind of ruthless efficiency prevents burned context while making the agent's behavior deterministic and fundamentally easier to debug.
Let's unpack that token economy, though, because you are heavily emphasizing the cost discount. Moving from 293 down to 54 tokens is mathematically a 5x reduction, sure. But what is the hidden capability tax you are paying for that discount?
I come at it from a different way. There is no capability tax. I think there's a capability gain. Dumping 2,379 tokens of unused schema into a context window isn't just wasting API credits. You are physically diluting the large language model's attention mechanism. We have to look at how these models actually work.
You mean the self-attention mechanism in the transformer?
Precisely. In a transformer architecture, The model computes the relationships between every single token in its context window. It has to pay attention to everything. So if your prompt is stuffed with 4 pages of dense JSON text describing the rename worksheet tool, the delete row tool, and the validate formula syntax tool, the model has to spend computational effort actively deciding to ignore those tools when the user simply asked it to format a cell.
It has to sort through the noise.
Exactly. You are creating cognitive noise. The more tokens in the prompt, the harder it is for the model to isolate the exact parameter it needs for the task at hand. That noise is the literal birthplace of hallucinations. The minimal path guarantees you only pay for exactly what you use. The agent operates with blinders on.
I see why you think that, but let me give you a different perspective. Those blinders are incredibly dangerous when you're dealing with the realities of unstructured data. I understand the math behind attention dilution, but giving the agent all 25 schemas is like handing a master chef the entire encyclopedia of culinary arts. Yes, it takes a moment to process, but they have the knowledge to adapt.
I don't know if that analogy holds up.
Well, your minimal path is like handing that chef exactly 3 ingredients, a pan and no recipe, and just hoping nothing unexpected happens.
Except software engineering isn't jazz cooking. It is about defined inputs and expected outputs.
But AI agents are deployed specifically because the inputs aren't always perfectly defined. Look at the actual operations in this repository. Let's say a developer provisions a minimal path workflow to format a financial report. They give the agent an 18-token doc for format range and another for write data to Excel.
Okay.
The agent opens the Excel file and discovers that the previous human user arbitrarily merged a bunch of header cells. Merge cells break standard writing logic in OpenPyXL. In the full server approach, the agent has the get merge cells and unmerge cells tools sitting right there in its peripheral vision.
It sees them in the schema.
Yes. It encounters the write error, reasons about the merge cells, dynamically discovers the unmerge tool, fixes the sheet, and completes the task. Under your minimal path, the agent completely crashes. It doesn't even know the concept of unmerging exists.
It fails gracefully, and I would argue that it's exactly what a production system should do when it encounters an unhandled edge case.
Wait, you want the agent to fail? Doesn't that defeat the entire purpose of utilizing a reasoning engine? If we wanted a system to crash the moment it encountered a merged cell, we wouldn't need an LLM. We would just write a traditional, rigid Python script. The promise of an agent is dynamic recovery.
The promise of an agent in a business context is reliable automation, not unconstrained improvisation. If an agent hits a corrupted file, I want the orchestrating application to flag it and handle the state transition. I do not want an LLM guessing at how to restructure the critical financial document just because it happened to have a sledgehammer tool lying around in its context window.
So you prefer brittleness to autonomy.
I prefer determinism to chaos. Which brings us to the nightmare of debugging complex workflows. Look, if you use the full server approach and the agent fails in the middle of a 5-step data manipulation pipeline, how do you debug it?
You look at the trace.
But say it tries to insert rows, but hallucinates a non-existent parameter for delete sheet columns because the schema's blurred together in its attention matrix. Tracing which of those 25 schemas confuse the neural network is impossible. You are debugging probabilistic opacity.
I mean, you look at the trace of the tool call. The LLM outputs a JSON payload. You can see exactly what it attempted to call.
But you don't know why it decided to format the JSON that way, which makes preventing it from happening again incredibly difficult. The minimal path entirely eliminates this vector of failure. For listeners trying to visualize this architecture, imagine a completely siloed pipeline.
Okay.
The repository requires Python 3.10 and above, and it uses absolute paths for these minimal tools. You feed the LLM a tiny 18-token text file from the Slate folder. The LLM reads it, figures out the command, and then an entirely separate hard-coded shell script like run/xlcli.sh takes over.
Passing the baton?
Precisely. If the operation fails, you know exactly which 18 tokens were in the prompt. You know exactly which shell script was invoked. You aren't debugging the opaque reasoning of a neural network anymore. You are debugging a standard software pipeline. You have isolated the LLM into a tiny controlled translation step.
That's an interesting point, though. I would frame it differently. Call it determinism if you want, but in this context that sounds suspiciously like a euphemism for hard coding.
I wouldn't say that.
No, think about it. If a software engineer has to manually orchestrate the control flow, like if they are the one writing the logic that says, load this specific slate doc, invoke this shell script, check the result, then load the next specific slate doc, they are just writing a traditional procedural script.
They're managing the workflow.
But the human is carrying the entire cognitive load of the architecture. The AI isn't an agent anymore. It is just a very slow, highly expensive text parser being dragged along a track you laid down for it. You are entirely failing to leverage the reasoning capabilities you are paying OpenAI or Anthropic for.
That is a very strong claim. But in a production environment where latency costs money and hallucinations corrupt data, I will take hard-coded reliability over probabilistic improvisation every single time. And I completely reject the idea that we are failing to leverage the AI's reasoning.
Really?
Yeah, the AI is still performing the hardest part of the job, which is unstructured to structured data translation. It is still mapping the user's messy natural language request, like, make the top row blue and bold, into the rigid parameters of the tool.
But is it? Let's look at the reality of how these tools actually function, because we aren't just talking about simple commands like create workbook. This repository contains highly intricate operations. Let's look at create chart or apply formula.
Both of which are fully supported by the minimal path, I might add.
Supported on paper, maybe, but an Excel chart requires nuanced parameter understanding. You need to define the data ranges, the axis references, the title strings, the chart type, the insertion cell. Stripping the context down to a skeletal 18-token summary in a slate markdown file severely risks starving the model.
Starving it of what?
I'm sorry, but I just don't buy that. Let me tell you why. That assumes the intelligence of the system has to live entirely inside the LLM's prompt. If you look at the actual architecture of Phraso/Excel agent skills, it reveals a fundamentally different approach. The documentation explicitly states that the minimal path scripts in the run directory share the exact same underlying execution logic as the server process. There is zero loss of code fidelity. But the LLM doesn't have access to the code execution. It only sees the tiny prompt you give it. If the prompt is sparse, the LLM's output will be flawed.
And that is the genius of the separation of concerns here. Their repository includes an extensive analysis/context report.md alongside a document called notes/whenfullsurface.md. These files explicitly prove that the minimal footprint is mathematically sufficient to execute the OpenPyXL code.
With just 18 tokens?
Yes. The 18-token slate document doesn't need to explain the mechanics of Excel charts. It just needs to provide enough syntactical scaffolding for the LLM to output a simple string or JSON object. The burden of execution, the actual heavy lifting of mapping that string to the complex OpenPyXL chart objects, is shifted out of the prompt and into the deterministic Python backend where it belongs.
So the Python runner does the translation?
Exactly. You don't need the LLM to juggle massive context windows about Excel internals if your backend Python runner is robustly engineered to handle the parsing. The minimal path actually forces developers to build better, more resilient backend tools rather than just lazily relying on the LLM to read a giant manual and figure it out on the fly.
Well, I will concede that shifting execution logic into a robust backend is excellent software engineering practice. You definitely want your Python code to be resilient, but even the most robust backend tool requires semantically correct inputs. If the agent is trying to execute validate Excel range or get data validation info, it has to understand what those concepts mean relationally within the user's specific spreadsheet.
How so, though?
Because context matters. The full server approach, deploying the entire schema, gives the agent semantic richness. It allows the agent to cross-reference its own capabilities before it acts. An agent might read the schema for create table and autonomously realize, based on these parameters, I should probably call validate Excel range first to ensure the data is contiguous, otherwise the table creation will throw an error.
But you can script that logic.
An 18-token isolated document physically cannot contain that relational context. The agent can't plan a multi-step sequence if it can only see one step ahead.
Which is exactly why the author included notes/whenfullsurface.md. There is a clear acknowledgement that if you're building an open-ended data analyst bot for a chat interface, you might want the full surface area. But we are talking about building cost-efficient AI agents.
Right, production scale.
For scalable engineering, providing the full schema is an architectural luxury, not a necessity. If you are running a background agent thousands of times a day to process incoming financial reports, you cannot afford to pass 2,379 tokens of unused tool documentation on every single API call.
The costs would add up.
The latency buildup alone would bottleneck the entire system, to say nothing of the sheer financial cost. The minimal path utilizing the run/xl-cli.py runner gives you access to the exact same 25 operations, but tightly controlled.
It is tightly controlled, I'll give you that, but it sacrifices the core identity of what makes an agent an agent. We use the term agentic to imply autonomy and problem-solving capability. If your system cannot dynamically discover that delete sheet rows exists when it encounters corrupted spreadsheet data, simply because the orchestrating engineer only provisioned the read data from Excel document, then it isn't an agent.
It's a pipeline.
It is just a highly brittle natural language API. The full server approach embraces the messy reality of the real world. It says, here is the entire toolbox. I trust your reasoning engine to navigate the complexities of this document.
And I maintain that trusting a probabilistic reasoning engine with your entire database schema and an unconstrained tool surface is a recipe for catastrophic system failure. The minimal path is the ultimate defensive architecture. You give the LLM the exact 18-token slate document it needs for the immediate task at hand.
And nothing else.
And nothing else. If it needs to pivot, the orchestrating Python application handles the state transition, not the LLM. You isolate the AI to where it is most useful, and you bound it where it is most dangerous.
It really is a fascinating philosophical divide. We are looking at the exact same repository, the exact same 25 open PyYXL operations, and deriving two completely different paradigms for how to build software in the AI era.
It ultimately comes down to where you place your trust as an engineer. Do you trust the deterministic, auditable code you wrote, or the probabilistic black box model you are renting?
To summarize my position in light of our discussion, while token efficiency is undeniably important, deploying the full schema over standard I/O, HTTP, or MCP is the only way to guarantee the dynamic discoverability required for true autonomous problem-solving. It provides the massive contextual landscape that an agent needs to handle unpredictable edge cases, like formatting anomalies or merge cells, without requiring manual intervention. If you restrict the context, you throttle the intelligence.
And to summarize my stance, the minimal path is the pragmatist's choice for production engineering. By utilizing discrete slate directories and absolute path shell runners, software engineers achieve a massive 5x reduction in context usage. But more importantly, they deliver a highly deterministic, easily debuggable architecture. You mitigate the risk of attention dilution and hallucinations, and you force the complexity down into the Python backend rather than relying on an LLM to parse a bloated context window.
I think the one area where we definitively converge is that the Phraso/XLAgent skills repository is a masterful case study. By exposing both of these methodologies side by side within the exact same codebase, it perfectly illuminates the fundamental trade-offs of modern AI architecture.
It really does. It forces developers to actively choose their paradigm, rather than just defaulting to whatever their framework provides out of the box.
Absolutely. It is a very raw, transparent look at the token economy versus capability debate. It doesn't hide the costs. It puts the exact token counts right in the documentation.
The data is all there to replicate. It's just a matter of deciding what kind of system you are actually trying to build, a constrained, reliable pipeline or an open-ended reasoning loop.
For those of you who are deeply interested in optimizing your own agent implementations, we highly suggest you investigate the repository's analysis/contextreport.md.
It explores the exact methodology, provides the per-tool token tables, and allows you to trace exactly how the minimal and full server architectures measure up.
You can see all the math for yourself.
Exactly. Because at the end of the day, as a software engineer, you have to decide what kind of workspace you are provisioning. Are you going to painstakingly hand your agent a single, predefined tool, watching its every move to ensure it doesn't deviate from the script? Or are you willing to leave the entire comprehensive toolkit out on the workbench, step back, and see what it is actually capable of building?